Hello and welcome to Natural Philosophy with J. Allen, the show where together we get to learn all about the fundamental constructs of reality. And we should do this by exploring the maths and physics, otherwise known as natural philosophy. Not to be confused with regular philosophy, mind you. Oh no, natural philosophers of this day and age prefer to employ the scientific method. Put everything to the test, boys and girls. That is the key. That is the key. And lots of maths. Oh, how I so do love the maths. All that addition and subtraction and division and multiplication. How delectable. Anyway, without further ado, let us get on with the show, shall we? Right then, so for this first episode, I would like to share with you the formula for creating a slope of a curve at a point. Now, you probably know from your algebra days that slope is rise over run. Rise over run, or you can also call it, in more mathematical terms, delta y over delta x. So that's a better interpretation of what a slope is. So the delta y would be your change in your y-axis, your delta x will be your change in your x-axis. So, let me demonstrate. And later, I would like to also give you a small taste of the amazing applications that you can use this formula for. It's almost like magic, really, only you can actually use it in real life. So here we have a point A and we have a point B. And what we want is the delta x from these 2 points. We want the change. We want to know what distance that we traveled. That's the change, the distance that we traveled between these 2 points. So let's call this delta sub 0, t sub 0, and t sub 0 plus h. Okay, so sub 0 simply means the time hasn't started yet. T represents time, 0 represents that you haven't actually begun your journey from one point to the other. So, to get the distance between these 2 points, what you would want to do is simply subtract. If you have, let's say this was a 1 and this was a 4. If you wanted to know the distance between these 2 quantities, you would simply subtract 4 minus 1, and that would be 3, obviously. But we're not dealing with numbers, we're dealing with variables. So what we would do is we would take our final and subtract it from our initial, just like we did with the 4 and the 1. So we would have t sub 0 plus h minus t sub 0, and that would give us h, because we have a positive t sub 0 and we have a negative t sub 0. So this would simply equal h. And that gives us our run, or our delta x, as it were. Now we want to find our delta y. What would that be? How would we get a delta y? Well, let's just call this point f, the function of t sub 0 plus h, t sub 0 plus h, and we'll call this point the function of t sub 0. Function of t sub 0. So f of t sub 0 is how we would say that. And now we want to find the difference, the change, the delta, as it were, in between these 2 points. So this is our final point. This is how far we've traveled in the y-axis. And this is how far, this is our initial point, I should say, of our y-axis. So we want to get the change in those 2 points. So all we do, quite simply, is we would take our final f of t sub 0 plus h, and we would subtract that by f of t sub 0. And so that would be our delta y. And we have our delta x already, so we'll just put that on the bottom, and there you have it. That is the formula for a slope of a curve at a particular point. And this will be used over and over and over again in calculus, even when you don't think you're using this formula, you actually are. And so now, let's try to use this in an amazing application where we'd actually be using physics. There we are. So, now I would like to show you how to use that formula that we derived to solve a problem such as this. So, if a ball is thrown into the air with a velocity of 40 feet per second, its height in feet, t seconds later is given by y equals 40t minus 16t squared. Now then, find the average velocity for the time period beginning when t equals 2 and lasting 0.5 seconds. So how are we going to do this? Well, like I said, we're going to use the formula. And obviously I can't fit anything else on here, so I'm so sorry. I'm going to have to make all of this disappear. So I hope you have it down. Okay, so this is where the real magic begins. So I want to re-illustrate that here's our formula that we derived, and I want to explain again that this is the distance that we would travel over the elapsed time. That's what h represents, the elapsed time. So all of this is explaining exactly how far you've gone because of these units of time. And so here is our equation that was given to us. I replaced y with f of t so that you could see that it is a function of time, as it were. So here's our initial time equals 2 seconds, and here's our elapsed time equals 0.5 seconds. And again, our equation is telling us that it's telling us how the ball is moving and how fast it's moving. So 40 feet per second times the initial time minus 16. That's not necessarily initial. I should explain. So it's just a time, a certain amount of time. 40 feet per second times a certain amount of time minus 16 times a certain amount of time squared. And that negative 16, what that represents is gravity. So that's interesting. That's what gravity will always look like when it's acting upon some object. So you could also say that it's what the curvature of space and time is doing to our ball. What the curvature of space and time is doing at this moment in time. So that is really, really interesting. Anyway, so I have to admit this is a little hard to explain. I hope that you can follow. What we're going to do is put all of this onto this side of the negative side, okay? And then all of this also on this side of the negative. So when we have it on this side, what we're going to do is we're going to plug t sub 0 plus h into that t, and we're going to plug t sub 0 plus h into that t. So that's what it's going to look like on that side of the negative. And then we'll have the same equation on this side, but instead of t sub 0 plus h, we'll have t sub 0. So we'll have t sub 0 plugged into that t, and t sub 0 plugged into that t. And then we'll have to do some mathematical finagling to get the answer. And everywhere where we have our initial time, t sub 0, we would plug 2 in, right? And every time we have h represents the elapsed time, we plug 0.5 in. So we have 0.5 there, we'd have 0.5 there. But because of this plugging in so many times, it becomes a very large formula. So this is what it would look like. 40 times t sub 0 plus h minus 16 times t sub 0 plus h squared. There it is. All of that, all of this plugs into those two t's. And then you would have minus 40 t sub 0 minus 16 t sub 0 squared. All over h. Okay, so what we're going to do, 40 times 2, because 2 is our initial time, we're plugging 2 into our initial time there, plus, and if you can see that, plus h, and h is 0.5. 0.5 minus 16, 2, because 2 is our initial time, plus 0.5 squared. Okay, so we don't have a lot of time here, so I'll tell you, of course, you have to distribute. You have to add the 2 and the 0.5 up, and then you would distribute, and then you would add up the 2 and the 0.5, and you would square those numbers. 2.5 obviously is just 2.5, and you would square that, and what that, all of that would give you is 0. Okay, so now we have, with this side of the minus sign, we would do 40 times 2 initial time minus, it's getting in the way, aren't you? Okay, so minus 16 times 2 squared. Oh, that's lovely. Okay. Now, what that would equal when you have 40 times 2 and you have your 16 times 4, that's what that would equal, of course, to this squared. 2 squared is 4. So what all of this would equal is negative 16. Let me make sure that. Yes, negative 16. What is negative 16? That's a rise. Remember, slope is rise over 1. So negative 16 is your rise. But what that also tells you is that's the distance traveled. Remember, that is the distance you traveled. Negative 16. We're going down. The ball is going down, so it's negative, right? And so we also have to do our h. And we were subtracting 0, of course. I hope you followed that. That this would be 0 over here, but 0 just means 0, so all you have is negative 16. And so our h is 0.5 seconds. 0.5 seconds. Okay, so negative 16 over 0.5 seconds gives you negative 32. And what does negative 32 represent again? What were we looking for? Oh, yes, right. We were looking for average velocity. So that's what that is right there. That is our average velocity. That means that is the speed, or not just speed, it's velocity, you have to say it right. That is the velocity that we're moving during this amount of time, during the elapsed time of 0.5 seconds, so 0.1, 0.2, 0. On and on to 0.5. That's the average rate of speed that you're moving in that amount of time. You could say average rate of speed plus the direction. That's what velocity is speed plus direction. The negative represents the direction that we're moving. So if you took the absolute value of negative 32, that would equal how fast you're actually going, 32 feet per second. So that would be your speed. Okay, so that's it. Now, next time, what I want to get into is using the same exact problem. We're going to look at instantaneous velocity. Oh, that's going to be even more fun, I assure you, because instantaneous velocity uses real calculus. We'll be using limits. And from limits, we'll go into figuring out how it is that you can go, that you can be at a particular point and how fast you're going at that particular point. Isn't that amazing that mathematics can tell you how fast you're going at a particular point? This gobbledygook right here, all of this, you plug numbers and values into that, and you actually can figure out things like exactly how fast you're going from all of this. Oh, it's so beautiful. Oh, I love it so. Anyway, that is all we have for today. I hope you enjoyed this episode, and come back for more. And if you could subscribe and give it a like. Thank you.